Question 6 is on coordinate geometry. Here you will be using the gradient formula, the midpoint formula, as well as if two lines are perpendicular to one another, then the gradient will actually, when you take the gradient of the two lines and you multiply to one another, it will be equals to -1. So without further ado, let's try question 6. Now I think question 6 is interesting because of the last part, and I think quite a lot of students will not be able to do the last question, and I think that is also very good that we go through this question. Okay, for the last part is quite difficult in my opinion, but for part 1 and part 2 it is okay. So question 6i, okay, so we have this diagram over here. It is actually a right angle triangle ABC, where the points A, B, and C are given as the points over here respectively. So BC cuts the y-axis at N, and M is a point on AC. Okay, so given that K is positive, find the value of K. Okay, so we can see that the line AB, right, is perpendicular to the line AC. Okay, so what I'm going to do is I'm going to find the gradient of AB using the coordinates of point A and point B, which is equals to 0 minus 8, y2 minus y1 over k minus 2, x2 minus x1. And gradient AC is actually equals to 0 minus 4, y2 minus y1 over x2 minus x1, k minus 2. Okay, and since we know that the line AB is perpendicular to the line AC, it means that the multiplication of the gradient AB with AC equals to -1. So gradient AB times gradient AC equals to -1, which means that 0 minus 8 over k minus 2 times 0 minus 4 over k minus 2 equals to -1. So this is -8 over k minus 2 times 4 over k plus 2. This is equals to -1. So this is -32 over k square minus 4 equals to -1, which means that -32 equals to 4 minus k square, which means that k square equals to 36. This means that k equals to plus minus square root 36, which is equals to 6 or -6. But because k is more than 0, we reject because k is more than 0. So we reject the negative, which is -6. So therefore k is equals to 6, and we are done with 6 part I. Quite okay. Okay, we are using the fact that two lines that are perpendicular to one another, the gradient of the two lines when you multiply them together equals to -1. And when you know this and you apply it, you can get the answer for part I easily after some calculations. So let's move on to part II. Okay, so find the coordinates of n. Okay, so we need to find the coordinates of n over here. So what I'm going to do for this is, first I'm going to let the coordinates of n be 0a. Okay, and we can clearly see that B, N, and C, right, they all lie on the same straight line BC, right, which means that we can say that the gradient Bn, okay, using point B and point N to find gradient Bn is equals to gradient BC. So to find gradient BC, we use point B and point C. Okay, so gradient Bn is actually 8. So let me just label the coordinates of point N over here. So gradient Bn using the coordinates of point B and point N is actually 8 minus A over 2 minus 0, and this is equals to gradient BC using the point B and point C is actually 8 minus 4 over 2 minus 2. So 8 minus A over 2 equals to 12 over 4. So this means that 8 minus A equals over 2 equals to 3, and 8 minus A equals to 6, which means that A equals to 2. So therefore, okay, A is 2. The coordinates of N is actually is 0, 2, and we have found the coordinates of N. Now we are required to show that N is the midpoint of BC, right? So how do we show it? So the midpoint formula, okay, let's find the midpoint of BC and let's show that that is equals to 0, 2. Okay, so midpoint of BC, you simply take the x coordinates, the sum of the x coordinates of point B and point C. So 2 plus minus 2 divided by 2, and then you take the sum of the y coordinates. Okay, so here we sum the x coordinates of point B and C and we divide by 2, and for the y we sum the y coordinates of point B and C and we divide by 2 to get the y coordinate of the midpoint of BC. So this will be 8 plus minus 4 divided by 2. So this is actually equals to 0, 2. And yes, the midpoint of BC is indeed the coordinates of N. So N is indeed the midpoint of BC. And we are done with II. So III is actually considered the hardest question that I would like to go through in this question 6, and most of the students will not, most likely will not be able to do this question because it's considered difficult and it requires you to use certain tricks to solve this question, and without knowing that trick you will not be able to get the answer at all. Okay, so given that the area of the quadrilateral ABNM is 25 units square, so A, B, M, N is 25 units square. Find the coordinates of N, right? So the first thing that I'm going to do is I'm going to evaluate the gradient of the line AC first. Okay, I'm going to evaluate the gradient of the line AC first. So the gradient of AC is actually equals to, so K is actually, this is actually 6, 0. Let me label the coordinates of all the points that we have found. So the gradient of AC is actually 0 minus 4 over 6 minus 2. So this is equals to 4 over 8. which is equals to 1 over 2, which means that the equation of AC, okay, is actually y minus 0, okay, meaning y minus the y coordinate of the point A, and x minus the x coordinate of point A. So this actually equals to 1 over 2, which is the gradient. So the equation of the line AC after solving is actually y equals to 1 over 2x minus 3. Okay, so this means that because since point M lies on the line AC, right, let B be the x coordinate of point M, right? So therefore sub B in y equals to 1 over 2, sorry, so this means that sub x equals to B, because we have let the x coordinate of point M to be B. So, and we know that the point M lies on the line AC, right? So sub x equals to B into equation AC, okay, we can get the y coordinate of point M, which is in this form, y equals to 1 over 2 B minus 3. This means that point M has this coordinate B and 1 over 2 B minus 3. So this is the part that students might not be able to figure it out. Okay, you have to find the gradient AC, and then you find the equation of the line AC. Then using the equation of the line AC, you have to come up a way to so-called define the coordinates of point M. Okay, you need this step. This is the trick. Without this, you cannot solve question part 3. Okay, so now we know that point M is in this form, B 1 over 2 B minus 3, and we have the coordinates of point N, the coordinates of point B, and the coordinates of point A, right? We can now use the shoelace formula to solve for the unknown B, and once we are able to solve for the unknown B, we can solve for the coordinates of point M. Okay, so using the shoelace formula, okay, so we write down the area first, the area of quadrilateral ABNM equals to 25 units square. So using the shoelace formula, okay, remember we must select a point first, after which we move in a anti-clockwise direction and then back to the point that we have selected. So let's say if we select point A as our point, so then this is the x coordinate of point A, the y coordinate of point A, and then we move anti-clockwise to the next point. So point B to 8, and then anti-clockwise again to point N. So 0, 2, and anti-clockwise to point M, which is B 1 over 2 B minus 3, and finally anti-clockwise back to the starting point 6, 0. So this is the shoelace method to find the areas of a quadrilateral. So this is 25. So now we're going to do the cross multiplication. So actually after evaluating, right, okay, so half bracket, so let's do it, 6 times 8 plus 2 times 2 plus 0 times this is nothing, plus B times 0 is nothing, and we have so let me put so this I write as a curly bracket. I'm going to put a square bracket here, minus 2 times 0 is nothing, 0 times 8 is nothing, b times 2 is b, right? Yeah, b times 2 is b. So b times 2 is 2b, and finally 6 times this plus 6 times half b minus 3. So this is actually equals to 25. So simplifying this, we get half square bracket 8 times 6 is actually 48 plus 4, which is 2 times 2. So this is actually 52, right? So it's actually 52 put a square bracket here, so 52 minus, so this is actually 5b minus 18, right? Yes, 5b minus 18, and this whole thing is equals to 25. So this simplifies to 70 minus 5b equals to 50. Yep. So this implies that 5b equals to 20, which means that b is actually equals to 4, right? So in that case, the coordinate of point M is actually 4, and sub 4 here, it will be 4 divided by 2, 2 minus 3 is minus 1. So that will be the coordinates of point M. Okay, and we are done with the last part of the question, 6 part 3, which is quite challenging, but most of the students might not be able to figure this part out, to find point M in terms of this form using the equation of the line AC. Okay, most of the students will not figure this out, so it's good that you walk through this question again and do it by yourself to know this trick, because if this question were to come out in the national exam, I believe that it will be considered a challenging question, but it is still doable if you know what tricks to use. And that's it for question number 6.